Hello, my name is Fred. In this Khan Academy video, we will discuss using equations based on data within Excel to determine certain important values. In this video, we will use data from the potentiometric titration lab, in which we used a redox reaction to form ferrocyanide from ferricyanide. Here we go. Here is the data. We are first creating a calibration curve based on the UV-Vis data from the 4 standard solutions of varying amounts of ferricyanide, and each of those amounts are listed in column A. In column B, we see each sample's corresponding absorbance value based on UV-Vis spectroscopy. And our goal here is to find the extinction coefficient, also known as the molar absorptivity, and to do so we will use Beer's law, where A equals E times B times C, where A is the absorbance of a sample, B is the path length of the cuvette, C is the concentration of the sample, and E is the all-important molar absorptivity. We can think of Beer's law as a linear relationship with the formula Y equals mx plus B, where Y, the dependent variable, is absorbance, x, the independent variable, is C times B, where B is the path length, keep that in mind, and m, the slope, is the extinction coefficient. So if we graph concentration versus absorbance and find the linear equation, we will know the molar absorptivity. So here I've plotted the calibration curve with the concentration on the x-axis and absorbance on the y-axis. The next step is to find the linear formula, which Excel can automatically calculate for us. So it's a bit different in each version of Excel, but I'll first click on the graph, then go to Chart Design within the ribbon, navigate to Add Chart Element, go down to Trend Line, and then select More Trend Line Options. From here, I'll scroll down and click Display Equation on Chart, and then I'll make this a little bit larger. There we go. Cool. So the slope, as we see there, is 0.972. Great. Cool. So there we go. Keeping in mind units though, and typically the extinction coefficient is reported in units of liters over moles times centimeters. We'll have to do a little multiplication, get rid of the millimolar, and that is our answer. Wow, way to go. Okay, moving on to titration, in which ferricyanide solution and ascorbic acid were combined in several proportions. Both the electric potential and UV-Vis data were taken. The goal now is to find the also all-important reduction potential, and we know that the reduction potential occurs when the natural log of the ratio of ferrocyanide over ferricyanide is equal to 0. We know that the natural log of 1 is equal to 0, and if a ratio is equal to 1, then both of those components must be the same value. So, once again, thinking of this relationship as a linear relationship, B, which is the y-intercept, must be the reduction potential. So if we graph the natural log of ferrocyanide over ferricyanide versus potential, and keep in mind we are looking for the y-intercept here, the B value. In the last data set we cared more so about the slope, but not here. So just like before, I'll click on the graph, navigate to Chart Design, Add Chart Element, Trend Line, More Trend Line Options, Display Equation on Chart. I'm going to double click that, increase the font size, and we come to 265.32. Great, and that's our answer. Of course, make sure to label all your axes and save all your data once you're done. Good luck.